Here's an example of a telescoping series. You're given sum k equal 2 to infinity of the natural log of 1 minus 1 over k squared, and you're asked to find part A, the partial sum S sub n, part B, the limit as n approaches infinity of the partial sum S sub n. Solution part A. First, notice that we can make a modification to 1 minus 1 over k squared. That can be rewritten as 1 squared minus parenthesis 1 over k squared, which can be factored as 1 minus 1 over k times 1 plus 1 over k. And then getting a common denominator, this would be k minus 1 over k times k plus 1 over k. And we could also, if we cared to, in this case it would be convenient to rewrite this as k minus 1 over k divided by the reciprocal k over k plus 1. Thus, the natural log, the sum of the natural log from k equal 2 to infinity of the original 1 minus 1 over k squared is equal to the sum k equal 2 to infinity of the natural log of k minus 1 over k minus the natural log of k over k plus 1. Because of the rules of logarithm, it says that when you have the log of a over b, it's a log of a minus a log of b. And that implies that s sub k is equal to, well, let's expand this thing, start with n equal, or k equal 2. I should call this s sub n. Let's call it s sub n. Start with k equal 2, and we'll have the natural log of 2 minus 1 is 1 over 2 minus the natural log of 2 over 3. Add that to the term when k is equal to 3. 3 would be the next one. And we get the natural log of 3 minus 1, which is 2 over 3, minus the natural log of 3 over 4, plus dot, 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 until we get to the nth term. We have the natural log of n minus 1 over n minus the natural log of n over n plus 1. And you'll see that this is being a telescoping series now. We have cancellation of all these inner terms, and it turns out that s sub n simplifies when it collapses telescopically. It simplifies to the natural log of 1/2 minus the natural log of n over n plus 1. And this is true for n greater than or equal to 2. So that's the answer to the first part, the nth partial sum. Part B, now we'll take the limit as n approaches infinity of s sub n. It's equal to the limit as n approaches infinity of the natural log of 1/2 minus the natural log of n over n plus 1. And that is equal to, let's see, well, if we did a direct substitution, we would get the natural log of 1/2 minus the natural log of infinity over infinity, and that's bad. We don't want infinity over infinity, so let's make an adjustment. This is equal to limit as n approaches infinity of the natural log of 1 over 2 minus the natural log of, let's see, we'll divide the top and bottom by n. We'll get n over n over n over n plus 1 over n. And that equals the limit of the natural log of 1/2 minus the natural log of 1 over 1 plus 1 over n. And let's let n go to infinity and see what we get. We get the natural log of 1/2, because that's independent of n, minus the natural log of 1 over 1 plus 1 over infinity. This part goes to 0. So that's the natural log of 1/2 minus the natural log of 1 over 1, which is 1. But the natural log of 1 is just 0 because e to the 0 is 1. So our answer is the natural log of 1/2. We can write it this way, or we could play with it. This is the same as 2 to the negative 1. We could bring the negative 1 out in front and call this negative natural log of 2. Either way. And we're finished.